Hello students, we were in module 4. In that we have already discussed infinite series. Under that one test we have already done, that is ratio test. Regarding ratio test, D'Alembert's ratio test, the problems we have solved in the last recording. Now we will see the next test, Cauchys root test. So in the infinite series, you need to study two tests. One is ratio test, another one is root test. Now what do you mean by Cauchys root test? In a positive series, if I take a series, as you have seen in ratio test also, summation un, if summation limit n tending to infinity to the power 1 by n, if the value of this limit, now summation is not there here, okay, summation is not there here. If limit un to the power 1 by n, when n tending to infinity is equal to lambda, then we say the series summation un is convergent if lambda less than 1, and when it is divergent if lambda greater than 1. So please note that this is not there, okay, so please remove the summation term. So when we say the Cauchys root test convergent, according to Cauchys root test, summation un is convergent if the value of this limit is less than 1, and it is divergent if lambda is greater than 1. Now, before going to the problems, we need to note down some important points. In that first point is, in the Cauchys root test is applicable when un is of the form this. Whenever the nth term, un means nth term, if the nth term is in this form, function of n to the power function of n, whenever un is of this form, we will apply which kind of test? Cauchys root test. So remember, when we are applying Cauchys root test, whenever the nth term is of this form, power is n, and here also if you are having n, then we are usually apply which test? Ratio to root test, okay. And when we are applying ratio test, we remember when we are applying ratio test, when it is of the form factorial, or whenever it is of the form nth term form, ratio form, then in that case we will apply ratio test. So here we will apply root test, Cauchys root test. So whenever un is of this form. Now some of the standard limits you need to remember while solving the problems. Limit n tending to infinity n to the power 1 by n. The value of this limit, this is a standard limit. We have already studied in second PUC. Limit n tending to infinity n to the power 1 by n is equal to 1. Now next limit is limit n tending to infinity, right? 1 plus 1 by n to the power n. The value of this limit is e exponential, e power 1. The value is somewhat 2.7. And then limit n tending to infinity, 1 plus x by n to the power n. The value of this limit is c. Whenever it is 1, here e power 1. Whenever it is x, here it is e power x. So these are the standard limits you need to remember. We are using in the problems. Then what is the value of e power minus infinity? We know what is the value of e power minus? It is nothing 1 by e power infinity, right? What is 1 by e power infinity? We know what is e power infinity? Infinity. So what is 1 by infinity? Value 0. So always e power minus infinity is 0. And what about a power infinity? That is also 0. When a is less than 1. This is the main condition. When a is less than 1, this a power infinity we can write 1 by a power infinity, because a is a fraction, right? Whenever it is less than 1, what do you mean by less than 1? 0 to 1. It is a fraction, correct now? So whenever it is a fraction, infinity comes to the denominator. So 1 by infinity becomes what? 0. Okay, 1 by infinity becomes 0. And then limit log in n tending to infinity. This value of the limit is infinity. This also you need to remember. See, whenever we'll say e power infinity, when you apply log term, what you get? Log e to the power infinity is infinity into log e to the base e, correct na? So equal to infinity. So limit n tending to infinity log n to the base e power infinity equal to n. So when n tending to infinity, e power infinity becomes infinity. So remember this, whenever limit n tending to infinity, log n will be, value will be infinity. Now after noting down all these points, let me go for the problems. test for convergence, convergence of the series. Test for convergence of the series. Now first one is summation n cube divided by n to the power n. Can you see here power is there, right? This you can do by ratio test also. Okay, this problem you can do it by ratio test also. Now I'll do by root test. So the problem you can do either in ratio test or root test, because they are not mentioned, right? Just they are mentioned test for convergence of the series. So this particular problem we can do it by ratio test as well as root test. Now this problem I'll do it in root test. You can try by ratio test also. Now let me take un, since it has a power, so I take this is a nth term, they have given un. Now in the root test we need un to the power 1 by n, correct? So I raise the power by 1 by n. So that time what you will get? This power 1 by n. So you will get n to the power 3 by n divided by 3 to the power n by n. So n cancels, you will get n to the power 3 by n by 3. Now by Cauchys root test, limit n tending to infinity un to the power 1. So this is our root test. This is a root. Root is there, na? Root test. Root of n, correct? So root test. Limit n tending to infinity un to the power 1 by n. Limit n tending to infinity un to the power 1 by n. What we got? This one, right? So substitute here. Now this one I'll write it as n to the power 1 by n to the power 3. Okay, because if I put directly n equal to infinity, I'll get infinity, right? It's not possible. So what I'll do is I'll do some modification here. Instead of this, I'll write n to the power 1 by n to the power 3. Now what is the value of this limit n tending to infinity n to the power 1 by n? This is the standard limit, right? I told you to remember. So what is the value of this limit? 1. Correct na? So 1 to the power 3, that is 1 divided by 3. Correct na? So we have applied the limit here, that gives you the value 1 by 3. Now what is 1 by 3? Is it 0.3? So is it less than 1? If the limit is less than 1, then what we can say? The given series is convergent by Cauchys root test. So you need to mention as the given series is convergent by Cauchys root test. Now let me see the next problem. Un is equal to log n to the power minus 10. So here the nth term is given. So calculate un to the power 1 by n. Then when you calculate that, you will get, see, un is this, substitute un to the power 1. So n cancels, you will get log n to the power minus 2. So by Cauchys root test, how you can write? Limit n tending to infinity un to the power 1 by n. Un to the power 1 by n, what we got? This. Substitute log n to the power minus 2. Now this is same as what? Limit n tending to infinity log n. What is the value of this limit? I told you in the note, right? You need to remember. Limit n tending to infinity log n equal to infinity, right? Na? Infinity. So infinity to the power minus 2 is the same as 1 by infinity. What is the value of 1 by infinity? 1 by infinity is 0, right? 0, is it less than 1? Correct, na? 0 is always less than 1. So what we can conclude, this limit is less than 1. So by Cauchys root test, the given series is convergent. If the value of the limit is less than 1, then we can say it is convergent. Now let me do the next problem. Test for the convergence of this series. So nth term is given here, power is there, so I'll use root test. Okay, power is there. Always whenever power is there, better to use root test. Okay, whenever the power is n, we can use root test. Now let me take un equal to this, then raise the power by 1 by n. When you raise the power by 1 by n, see, n cancels, so you will get n plus 1 by n to the power n. Here n cancels, you will get 1 by 3, right now. So the by Cauchys root test, apply the formula un to the power 1 by n. We got it, this, substitute. Now what we can do here? We cannot keep like this only. So what we have done in ratio test, we remember in the last recording, we have taken out n cancels, 1 plus 1 by n whole to the power n. Now when you apply the limit here, what you get? We remember what is the value of this limit, 1 plus 1 by n to the power n. I told you to remember the value of this limit. The value of the limit is e, right? So we can write in the place of this e, 1 by 3 is a constant, we can take out. So I'll get this. So what is the value of this limit? According to the node, it is E. So E by 7. E means 2.7 somewhat approximately 2.7. 2.7 by 3. That value will be less than 1. You can calculate using your calculator. You will get 2.7 by 3, which is less than 1. Therefore, the given series is convergent by CRT. That is Cauchys root test. Now, next problem, test for convergence of this series. Here also the power is n, right? Power is n, and here also function of n. So we can use clearly root test. Now let me take un equal to this. Then raise the power by 1 by n. So what you get if you raise the power by n by 1 by n? So 1 plus 1 by root n, see, minus n to the power 3 by 2 and n to the power minus 1. Do you agree? 1 by n means what? N to the power minus 1. So what is the total power? 3 by 2 minus 1. Take the common denominator. So 2 by 2. 3 minus 2 is 1. 1 by 2. So this power will be simplified to minus n to the power half. So you will get un to the power 1 by n is equal to 1 plus 1 by root n to the power minus root n. So by Cauchys root test, this is the formula for Cauchys root test. Limit n tending to infinity un to the power 1 by n is equal to limit n tending to infinity 1 plus 1 by root n to the power root n. So we have raised the power by 1 by n. And we got like this. So 1 plus 1 by root n to the power minus root n. So what is the value of this limit? Anybody? So limit n tending to infinity 1 plus 1 by root n to the power minus 1 I have written. What is the value of this limit? Is it same as e? Correct now? So e power minus 1. What is the value of e power minus 1 by? What is the value of 1 by 2.7? It is less than 1. So by Cauchys root test, the given series is convergent. So by Cauchys root test, the given series is convergent. Now next problem, find the nature of this series. Again power is there, so we can apply Cauchys root test and the given a is less than 1. So let me take un equal to this. Raise the power by 1 by n. When you raise the power by 1 by n square, n into n. So 1 n cancels, a power n, x power n into 1 by n cancels, you will get x. So by Cauchys root test, limit un to the power 1 by n can be written as a power n into x. But a is less than 1, right? It is given. So it is 1 by a power n, correct? So when you apply infinity, you get 1 by infinity 0. A is less than 1, correct? 1 by a power, so 1 by infinity 0. So 0 into something 0. So whether 0 is less than 1, so what we can take? The given series is convergent. Now next one important, discuss the nature of the following series. So here nth term is not given. Can you make out? Here nth term is not given, but they have given the pattern of the terms, correct? So can you write down nth term? See, can you see the second term, third term? See here when it is 3, here it is 2. When here it is 3, here it is 2. Here the same power. Here see. When here it is 4, here it is 3. Here it is same power. Can you see? So what will be un? Can you make out what will be un? So here I can write n. See denominator I can write n. If it is n, here it is 1 more. So n plus 1. And here the same as this term, correct? So same as this term. So n plus 1 minus, can you see here it is 3 by 2, 3 by 2. Here it is 4 by 3, here it is 4 by 3. So I can write, is it n plus 1 by n? Do you agree? N plus 1 by n. Okay, to the power. Here it is 2, here it is 3. Can you make out? So this is the denominator thing. Can you make out? So here you need to write denominator thing. What is that? N. Correct? So un is equal to n plus 1 by n to the power n, then n plus 1 by n to the power 1. So the total power is n plus 1. Okay, n plus 1 by n to the power n plus 1 by n to the power 1. So total power I've written in the form like this, then minus n plus 1 by n. Now which is common here? N plus 1 by n is common. You take out. This you will get inside. Now raise the power by minus n. Okay. Now here I can simplify n. You can take out n cancels. You will get 1 plus 1 by n to the power minus n. Then here also n cancel, you get 1 plus 1 by n whole power n minus 1 whole power minus n. So this is un now. Now we need to raise the power by 1 by n because we are applying Cauchys root test, correct? So we'll raise the power by 1 by n. So n cancel, you will get this. This is our answer. Now apply Cauchys root test. Limit n tending to infinity un to the power 1 by n. What is un to the power 1 by n? This one, right? So in the place of this, you substitute this term. So I'll get this. Now what is the value of this limit? You know. What is the value of this? You put n equal to infinity. 1 by infinity is 0, right? So 1 plus 0 to the power minus 1. Is it 1 itself? 1 to the power minus 1 is 1 itself. Now what about the value of this limit? 1 plus 1 by to the power n. When limit n tending to infinity, what is the value of this limit? Is it e? From the note it is e, right? Minus 1 to the power minus 1. So this value is 1. 1 into something is this itself. So write like that, e minus 1 to the power minus 1. So 1 by e minus 1. Now simplify 1 by 2.7 minus 1. You will get 1 by 1. So it is again less than 1. If it is less than 1, what you can conclude? The given series is convergent. Now last problem, test important. Test the convergence and divergence of the series. Here also the power is n is there. So let me apply root test. So here nth term is given. So write down nth term. Okay, nth term. Then raise the power by 1 by n. When you raise the power by 1 by n, it will get cancelled. You will get n to the power n plus 1 by n. N plus 1 by n becomes 1 plus 1 by n. So n plus 1 by n x. I have written this as n power 1, n power 1 by n. Now apply Cauchys root test. Un to the power 1 by n, substitute n plus 1x divided by n into n to the power 1 by n. Okay, so n plus 1 by n, x by n to the power 1 by n. I have written separately. Now take out n cancels. You will get 1 plus 1 by n. When you apply the limit, what happens? 1 plus 1 by infinity. Is it 1 by infinity is 0? So do you get 1 here? And what is the value of this limit? Limit n tending to infinity to the power 1 by n. Already I told you in the beginning. This is a standard limit. So what is the value of this limit? 0, right? Value of this limit is 0. Sorry, value of this limit is 1, correct? Sorry, I've written wrongly. So what is the value of this limit? Limit n tending to infinity n to the power 1, it is 1, correct now? 1 it is. So make a correction here. Make a correction here. So make a correction. We'll get the value as limit n tending to infinity n to the power 1 by n is always 1. Okay, this is 1, 1. Make a correction, 1. So you'll get limit n tending to infinity. This value is 1. Only you are left out with x because limit depends upon n. So the x nothing to do with it. Take out x. Now the given series is convergent if x less than 1 and divergent for x greater than 1. Okay, so the given series is convergent for. So this limit, if it is less than 1, then we say the given is convergent and divergent for x greater than 1. And when x equal to 1, we can conclude that the test fails. Okay, test fails. If you want to check this x equal test 1 fails, I told you in ratio test, what you need to do? In the place of x, you need to put 1. Then use comparison test, you will get the answer. If you want, you can check it for x equal to 1. I have told you in one of the problem in ratio test. You can verify that. Okay, test fails. Now assignment 6. So these are the problems under assignment 6 and I have given 2 problems under ratio test, 2 problems under root test and I have given the hint also. Please try these problems and do it in your notebook. Okay, thank you.